does that do to your graph? So this one has a few more rules associated with it. It will take us a couple days to get through this section, probably 2 to 3 days, depending on how it's going. In general, all right, so this first slide, it is on that summary handout that's posted on Classroom, so you don't have to write this down. It is on Classroom. Rational function is just when we divide two polynomials. The key, of course, if we're dividing, we know the denominator can't be 0. So a rational function is anything of the form p of x over q of x, polynomial divided by a polynomial. We know polynomials themselves all have nice whole number exponents, so 0, 1, 2, 3, 4, so we don't have any radicals or anything like that. We're just dividing polynomials. The first thing that we have to talk about with those is the domain. So domain is talking about what x can be, what possible values. We've seen it before when we're talking about graphs. And we know that in a fraction, the denominator can't be 0. The places where your denominator is 0, those are the situations where your graph does funny things. So a lot of times we are going to start by trying to identify those points because we know it's going to cause our graph to do something different there. So if I asked you to find the domain of these rational functions, I'm asking you to find what x can be. So on A, all we have to look at is what? We only care about the denominator. The denominator can't be 0. So that means x can't be -5. Domain tells me what x can be. So it's everything but that. So it's -infinity to -5 union -5 to infinity. B, x squared minus 4 can't be 0. So what would you do? If you add a square root, what else do you need? So x can't be positive or -2. That one, if you're writing it as an interval, gets a little bit long. It's everything smaller than -2, everything between -2 and 2, and everything bigger than 2. The interval notation gets long when there are multiple values that x can't be. So if it's just one number x can't be, I do expect you to write that interval. If it's more than one number, you are okay to just tell me x can't equal and then list the things. Okay, so if it's just one, go ahead and write the interval. If it's more than one, interval is optional. Try like that C. denominator, x squared plus 1, can't be 0. So x squared can't be negative 1. What happens if you do the square root of a negative?
It becomes I.
It's I. Do I have to worry about imaginary numbers? No. So what do you think my domain is?
All those numbers.
So negative infinity to positive infinity. On D, we know the denominator can't be 0. So that means 3 can't be 0. Is 3 ever equal to 0? No, so what's my domain? Any issues with domains? Now, something that I want to talk about. If I gave you x squared minus 1 over x minus 1, could you factor and reduce that? Yeah, the top would factor into x plus 1, x minus 1 over x minus 1, and what happens to those x minus 1s? They cancel. So we're used to just saying this is equal to x plus 1. Agreed? Technically though, they're different. Because if you consider x squared minus 1 over x minus 1, what is my domain?
Everything but 1.
Okay, everything but 1. If you look at x squared plus 1, that's not even a fraction. What's the domain of that?
Everything but negative 1.
Actually, it can be anything because it's just a line. Its domain is everything. So technically, we're so used to saying those things are equal because we reduce, but their domains are different. It does change your graph. Oops. I said everything but 1, then I wrote negative infinity to infinity, didn't I? You guys are just going to let me do it too. All right, so the first one, you can't plug a 1 in there. If I do, I get 0 divided by 0, which doesn't work. But the second one, I can plug in a 1 and I get 2. When we graph our rational functions, we have to go off the original. The difference is actually this one. It turns into the same thing except at the 1 point when x is 1. This first one turns into a line with an open circle in it. It's called a hole in the graph because you can't plug 1 into that original equation. Now once I cancel those out, you just have a line. So over here, the graph has that line filled in. So the whole point of that discussion was just to say, when you're finding domains, I want it based off the original function, not what it reduces to. Because we're working on graphing them, and it does impact the graph as we go through. All right. Are we okay with domains? Second thing I want to talk about is asymptotes. This is on the notes handout posted on Classroom. So all the definitions are posted on Classroom. You don't have to write it down unless you just really want to. But asymptotes are lines that we are getting closer to without touching. There are 3 different types. So you guys probably talked about asymptotes a little bit in Algebra 2, right? You've heard of them. But we have horizontal, vertical, and oblique asymptotes. Sometimes oblique might be called slant asymptotes. Horizontal are just horizontal lines. Vertical, we know are vertical lines. Anything else falls into that oblique category, any other line. It is possible that a function might cross through a horizontal or an oblique asymptote, but it will never cross a vertical. So I know some of you are trying to write this down, so I'll leave it up here. We show asymptotes as dashed lines on our graphs. So we'll draw those so that when we're drawing our graph, we can correctly approach it and show that we are getting closer and closer. So the first example I want to do, I just want to look at a graph and see if we can pick out some information. Does it have a big one here? So if I look at this graph, domain and range. What do I mean by domain? What's domain? Everything X can be. All right, so if I'm looking at this, I'm coming in from negative infinity. This graph stops here and the next one picks up. It's not drawn in, but we can see if I drew the line at 2, do we ever hit 2? No. So my domain is everything but 2. So negative infinity to 2, union 2 to infinity. My range, what y value are we not hitting? So my range is negative infinity to 1, union 1 to infinity. X-intercept. Where does this graph touch the x-axis? 1. If you wanted to do an ordered pair, you would just say 1, 0. Y-intercept. Approximately, where does this hit the y-axis? Asymptotes. These are lines, so you have to make sure that you are giving me the full equation when I ask for them. So if I ask for the horizontal asymptote, what does the equation of a horizontal line look like? Y equals. Okay, what's the horizontal line we're not crossing? 1. All right, vertical. What's the equation of a vertical line? What's the vertical line we're not crossing? So x equals 2. Oblique. Do we have any slanted lines we're getting close to? No. So there is none. So now I want to talk about how to find asymptotes. This again is on that handout posted on Classroom. So it's up to you how much you want to write down. But we need to be able to look at the equations and find our asymptotes. So vertical asymptotes are vertical lines that we're getting close to. Those happen when we have values of x that don't exist. Okay, when I take things out of my domain, that was because on those previous domain problems it made the denominator 0, right? So vertical asymptotes are always the things that make the denominator 0. Did you get what you needed? So vertical asymptotes are x equals a number, because it's a vertical line, and it's what makes the denominator equal 0. Horizontal asymptotes. Horizontal means y equals a a number. And there's a couple different ways these happen. It all goes back to long division. Okay, if you divide polynomials, you get a quotient and a remainder. Basically, that quotient piece is your asymptote, because the remainder would actually change it. So the true quotient without the remainder is your asymptote. If the degree of the top is smaller than the bottom, it will always be y equals 0. The reason for this is from that division. So I just want to illustrate it for a second and I'll come back to this slide. If the degree on top, if I said like 5x divided by x squared plus 3x minus 1. Okay, the degree on top, my highest power is 1. The degree on the bottom is 2. If you go to divide those, can you do 5x divided by x squared? No, so your quotient is 0, everything's just remainder. That quotient becomes our asymptote. So if the degree on top is smaller, it's always 0 because you can't divide them. If you have the same degree on top and bottom, you divide the leading coefficients. So the reason is the same. Those asymptotes happen at our quotient when we have a remainder. So I'll come back to the slide in just a second. But if I said I wanted 6x plus 3 divided by 2x minus 1, and you go to set up your long division, what's 6x divided by 2x? 3. And then once you do that, when you get to this point, can you do 6 divided by 2x? No, so everything else is the remainder. So this 3 turned out to be my horizontal asymptote. So it's like the quotient if you ignore the remainder. That gives you the horizontal asymptote. All right, if the degree on top is is bigger, if this were like x squared, when I go to divide them, I'm going to have an x in here, right? So is that a horizontal line anymore? No. So I can only get a horizontal if the degree on top is smaller or they're the same. Oblique asymptotes are going to be normal lines, y equals mx plus b. We find these with long division. This happens if the degree on top is 1 bigger than the bottom. If I have, x squared divided by x, that'll put an x in my answer. If the degree on top is more than 1 bigger, so if it's like x squared over x, that's oblique. But if I said x to the third over x, when you divide them, what are you going to get? X squared. Is that a line? No. So if the top degree is more than 1 bigger than the bottom, there will be no horizontal asymptote or oblique asymptote. And you can't get both horizontal and oblique. It's one or the other. because it's all based off that degree. It's based off what would happen if we divided them. What's the quotient if we throw out that remainder? So what I want to do now is just practice finding asymptotes. And that's what we're going to do for the rest of class. Next week, we'll actually start drawing our graphs. So I have tons of these examples. We will do as many or as few as you guys need, right? So if I just say, so if I said my function is x over x squared minus 4. Vertical asymptotes are what makes the bottom 0. If you set x squared minus 4 equal to 0, what do we get?
Plus and minus 2.
So those are my vertical asymptotes. Right. Just like finding the domain, except in domain you're telling me x can't be those things because the asymptote is there. So the asymptote is equal to those. All right, then we have to decide if it's horizontal or oblique. It will not be both. It's one or the other. So that's based off the degree. What is the degree of the top? So it's an x, so the degree is the exponent, so that's 1. The bottom is 2. If the top is smaller, what do I have?
Horizontal.
And it's always y equals 0. Okay, if you remember the rules, great, but it has to do with dividing these things. Even if you just think, I want to do x divided by x squared. Can you do x divided by x squared? No, so you get 0. Okay. Is that one okay? What if I said x plus 3 over x minus 1? What is my vertical asymptote? 1. So x equals 1. All right, then we have to decide horizontal or oblique. So what's the degree of the top? The bottom? 1. So if you remember the rule, great. If not, you could even just think about dividing. It's just like dividing these leading coefficients. What happens if you do x divided by x? It cancels and leaves you with 1. So it's just y equals 1. When we find that asymptote, we're just dividing those highest powers of x. 1x divided by 1x is 1. The x cancels out, so it's a horizontal line. Y equals 1. Let's say I gave you
The cross-country people are about to leave. Do we have homework today?
Let me write this. I'll give it to you, okay? All right, try to find your asymptotes for that one. Good luck today. What do I need to do to find my vertical? Factor the bottom. So that would be x plus 7, x minus 3. Okay.
Cross country is dismissed at this time. Cross country is dismissed.
So your vertical, what makes the bottom 0, do you girls just want it from the video or do you want me to write it down for you?
I can do it. Yeah.
Okay. So what makes the bottom 0?
Negative.
Okay, so I have two vertical asymptotes, x equals -7 and x equals 3. Good luck. All right, my horizontal. Let's go back to before it was factored. If you divide 2x squared divided by x squared, what happens? That just gives me 2. So my horizontal asymptote is y equals 2. Are we catching on to these? Okay. It's also okay to get a fraction on this. You know, if it were like a 3x squared, you can say 2/3 for your horizontal. That's fine. What if I said, let's do, what's my vertical asymptote? So we always make sure you write the full equation, so x equals 2. If you go to divide those leading coefficients, if I take x squared divided by x, what happens? We still have x. So is that horizontal? No, that's oblique. All right, to find an oblique, we are going to do long division, which we were practicing earlier. What's wrong, Chloe?
So how do we know it's oblique again?
When you go to divide the leading powers of x, if I just cancel those, I still have an x in it.
Yes.
So that means it's not horizontal. Horizontal is just y equals a number. So if you still have an x,
So if I
it's
got rid of all the x's, then it would be
horizontal.
horizontal.
Mhm.
Since I still have my x at one.
Right.
Okay. So if there's any x in the problem at all, or only if the x.
If it's
only
an x to the first. So if the top is one higher than the bottom, is when it
Okay.
happens.
So
If this
then,
were like x to the third over x, that's x squared. That's not a line, so we just say there's no horizontal or oblique.
So, but like the plus 3x doesn't change. that.
Doesn't change. Okay, so the good news is we don't have to do the full long division. I don't care about the remainder, I only care about the quotient. What is x squared divided by x? X. Then we multiply it. X times x is x squared. X times -2 is -2x. What do I do with that? Subtract it off. Those cancel. I get 5x plus 4. What is 5x divided by x? 5. That is all you need. You can stop right there. Because the rest of it's just going to give me my remainder, and I don't care about it. My oblique, then, is the line y equals x plus 5. Okay. Think we can stop for today?
Yeah.
All right. So we are going to keep working on this a lot. What I want you to do for today, we're going to do some book problems. But a lot of these are just looking at a graph and answering questions.
I can do this.
No, it's true. Yeah. Is it false? That's true.